So I'm still in my room that looks like a hospital, according to Alexi. I'm in London. Alexi, where are you this month?
Amsterdam, as usual.
Amsterdam. Cool. So that's Europe. We've got two Europes. Who else have we got? We've got Alon. Hello. Who else have we got down here? We've got Max. Todd.
Hi, Todd. Thanks for the feature. I'll cover it today.
Come to just check that you're going to cover the feature that they worked on.
Yeah, for sure.
Tadej is in Slovenia. We should have a YouTube link in a minute in case you want to watch it afterwards. I'll paste that on when we've got it. There it is. Hang on, let's paste that in here. So if you want to watch afterwards or share with any of your friends, you can use this link. We'll just give people hello from Paris. We'll give it maybe a couple of minutes just to give people a chance to get in. Like usual, if you have any questions, you can ask them on the chat or on YouTube, and then I will collect them and ask Alexi when we get a little pause.
So we have Paris, we have Slovenia, but which city in Slovenia? If you don't mind. Because I know only a single city in Slovenia. Ljubljana. Yeah, I could guess.
Is that the only city that you know?
Yeah.
Got it.
Hi, Max. Hi, Ramazan. Nice to see you again. Hi, Sergej. Hi, Vern. Miguel. Nice to see you. Kanvar. Arno. Nice to see you again. And you are supposedly, I know where you're from, but I will not expose these details.
Shall we get started then? Over
That's
to you.
okay. So today we have ClickHouse release 25.4. It is ClickHouse Spring release. It has a lot of features. Today we will also have a guest talk. So let's take a look. We have 25 new features, 23 performance optimizations, and 58 bug fixes. And let's start with small and nice features. The first one is an option to specify default compression codec in merge tree tables. So let's take a look where you can specify custom compression codecs. You can do it on a column level. So when you create a table, you have columns, and for every column, you can specify whatever compression codec you want. You can even specify a sequence of compression methods like delta compression and then ZSTD, and you can specify a level. In this case, it is ZSTD of level 3. If you don't specify a compression codec on a column level, the default compression codec will be used. And it was always possible to specify the default compression codec on a server level. So in a server configuration, in a configuration file, you can specify the default compression method or even multiple methods depending on the table part sizes, like ZSTD for data parts over 1 gigabyte and LZ4 for data parts less than 1 gigabyte. And now there is just a small difference. You can specify a compression codec on a table level, like here. Not a big deal. So let's move on. The next feature is a persistent default database in the ClickHouse local tool. So let me remind you, ClickHouse local is a ClickHouse engine in a command line application. So it's like ClickHouse client and ClickHouse server together. you run ClickHouse local, and you can process external data, you can process local data, you can create tables, you can create databases, everything is inside this application. And by default, if you run ClickHouse local, that is also available as a CH alias. If you install it, this alias will be available. By default, it creates a database in a temporary location. And this database does not contain any tables metadata on disk. It only keeps track of the tables in memory. Then you can create other databases of different types, like atomic databases or ordinary databases, create your tables, prepare data parts. But after the invocation, this temporary data is deleted. Now it is possible to reuse the location of the data. And let me show you how it works. So I will copy paste some commands to a terminal. I have ClickHouse local installed, and in this example, I will just use the default path. Actually, let's create a directory. And now, interesting, if I have something in this directory, let me remove it and start over. So let me do. I'll just copy paste some commands that I prepared. Let me use the path example. And now I can create tables, insert data as usual, like this. So everything works. I have my data. And the difference is that if I run it again, the data is still available. And if I look, what does it look like? You can see usual data directory of ClickHouse. So you can reuse the data parts created by ClickHouse local. You can, for example, copy these data parts to a server and then attach these data parts, or upload these data parts to S3 and then attach these data parts. It is quite useful. But again, it's quite a small feature. So let's take a look what is next. And the next is a control of server overload. It is named random early drop. So what does it do? We have two query level settings with some complex names: min OS CPU wait time ratio to throw, and max OS CPU wait time ratio to throw. And ClickHouse server will measure the ratio between currently running threads actively using CPU and the number of threads that are starving, that are waiting for CPU but not currently running, and calculate the ratio between these two numbers. So for example, if your server has 16 threads and there are 16 CPU cores actively used, and you have 100 of threads waiting for CPU, ready to run, but not running on the CPU, the ratio will be, who is good in arithmetics? 6 times? Yeah, probably 6 times. So the ratio will be 6. And when it is larger than the minimum threshold, the server will start randomly refusing some queries, some new queries. When it is approaching the maximum threshold, the server will refuse every query. And what is it for? It is to implement gradual degradation instead of like full server lockup. With this logic, the server will just start refusing some connections, and it will continue to be interactive. It will continue to be partially available instead of like everything works and then nothing works and you cannot do anything. Quite a useful feature. Let me try to show how it works. Now it could be tricky because I will start a server on this machine, on my machine, and I will try to overload this exact machine. It could be tricky because maybe I will be kicked off from this Zoom call. Who knows? But maybe it will work well. For this purpose, I will use the ClickHouse benchmark tool and try to run queries, specifically heavy queries that will calculate SHA-256 from 1 million numbers just to use CPU with 1,000 concurrent connections. And also I can override these settings on a query level. So I will specify a lower value of this threshold to start refusing some queries. So let me take the risk and try to run it. Okay, it runs 200 queries per second, and it refused some query. So it works well. It works as designed because CPU was overloaded. At least I was not kicked off from the call, so it worked. The next feature is quite a small feature. The possibility to specify inline credentials for the Kafka engine. When you create a table with the Kafka engine, in previous versions, the possibility to specify a username, password, or any parameters for SSL authentication, it was possible only in the server configuration. So in the server, you edit the configuration file and you specify these credentials. But what if you use a service like ClickHouse Cloud? Then you don't have access to to editing the configuration directly. You have access to SQL. And now you can specify credentials directly in the SQL query. Not a big feature, but it makes a difference. And yet another small feature. We have so many small features. And this is by Todd Yakum. So thank you for this feature. And let me try to explain. A new possibility to specify a host, an address, to bind client connections that server use to connect to other servers for distributed queries. So what is it for? For example, your servers have multiple network interfaces. And one network interface is used for example, internal connections or some VPN or whatever. And you want to use specifically this interface for inter-server connections. And now it is possible. You just specify the address as a bind host. It's quite easy. It works. Nice feature. Okay, now about performance optimizations. And you know that in every ClickHouse release, we optimize performance. So ClickHouse becomes faster and faster and faster. And every time there is something to surprise you. The first optimization is with a special column implementation, named lazy columns. So let me explain. let's suppose you have a query and you have this query has to read multiple columns. And some columns are used for calculations, like some applied on that columns. And some other columns just carried around with values. These values are filtered, but not modified. The column is filtered. And then these values just presented in the result. But it is possible that during this query pipeline, most of the values have been filtered, and it appears that you did not have to read all these values. Actually, this is not a single optimization for this. There are multiple optimizations that work for this purpose. But lazy columns are particularly interesting because we do something like this. We take a column, and instead of reading the data, we are just pretending that we will read the data. And we are carrying around the information, what exactly we need to do to read the data in a particular range. So this column can be carried around, it can be filtered, it can be cut to less number of values. But instead of real values, we will just take this information, and then when the values are actually needed, we will read them. Let me show you how it works. And it is particularly interesting because it is probably one of the most powerful optimizations. So first, let me go to a cloud service with the latest version. Here it is. And first, I will enable this optimization and run a query from a table named YouTube. This table contains information about YouTube videos, several billion of such videos, if I recall correctly. And it contains the description, the number of likes, dislikes, view count. And this query will just make a report on the most popular videos on YouTube. So let me ask Mark, do you have any idea about what is the most popular video on YouTube?
What is the it's probably a song, isn't it?
Yeah, it might
Like
be a song.
a music video.
Yeah.
I don't know. It used to be Gangnam Style. I don't know whether it still is. Oh, Tadej agrees with me. Oh no, I think Samai's gonna win. He said Baby Shark. Probably is Baby Shark.
What is interesting, I did not ever watch Baby Shark. Maybe I should.
Yeah, maybe you shouldn't. It's terrible.
Okay, so it's pretty
Hey, there it is.
30 gigabytes per second. And yes, Baby Shark dance.
Gangnam Style's number 10.
And then Despacito, I hate it. This is, I don't know what, but the best song for
Oh,
children.
I know this one as well. This one's really bad. This is even equally annoying as Baby Shark.
Masha and the Bear.
Thankfully, I haven't seen that one.
Okay, so this is the speed with optimization. 30 gigabytes per second, 2.5 seconds, 4.5 billion records. Yeah. Now let's try to disable this optimization just to look how it was in the previous release. It is not that fast. And you know, if you did not know that the release 25.4 is available, that this optimization is possible, that it is ready, and you did not know how faster it is, you will be pretty satisfied with this performance because it was feeling fast before the latest release. But in the latest release, we just have a new level of how fast it could be. And now we can really enjoy this speed. But let me show you a bit more. So let me go to ClickHouse Playground. This is the embedded ClickHouse UI. You can see it runs ClickHouse 25.5. I can make it full screen. And here is the table named mini crawl that contains HTML pages from the internet. And now we just take the most popular pages. So the most popular is google.com. And here is the HTML content. The second one is Akamai CDN. The next Facebook, YouTube, Netflix, Microsoft, GTLD. Interesting. Not even a single adult website. I'm surprised. But okay, it works. Twitter. Yeah, probably this Twitter could be quite obscene sometimes. Okay, but the main point, the query runs in just 10 milliseconds. Now let's try to disable this optimization and see what the difference is. And the difference is I cannot even disable this optimization in the playground. So because it is read-only. Let me go to the actual server and use direct connection. And now I will try to first run the query again. 0.6, 0.06, 6 to 7 milliseconds. And now I will try to run it without the optimization. And you know, the speed of reading data is pretty good, 24 gigabytes per second. But it takes so much longer. You know, I will interrupt it because I don't know, I don't want to wait. It could be 1,000 times slower. But you might ask that maybe this is not so realistic query. What about some real scenarios? So let me show you another one. We have a table named system.textLog, and it contains ClickHouse server logs. And this query should look like the query you might, or your colleague might want to run. Just take top 10 records by event time microseconds. And in this case, event time microseconds is not in the order key, is not in the primary key. It is just another column. And first of all, let's try to do it without optimizations. So this is what any observability system can do and wants to do on logs. So we have almost 7 seconds for 700 million records. It's not too slow. And we have these logs. Now let me try to enable this optimization. And with this optimization, does it work?
You pasted it with 0 by mistake, I think. Yeah.
Thank you. Now it took an instant. Yeah, and this is the difference. This is really powerful. Okay, but we have even more. Another optimization is for joins. And I promise it you, every ClickHouse release will contain at least one optimization for joins. So the release 25.4 as well. And actually this should be trivial, and I couldn't believe that we did not have it before. Let me demonstrate it to you. It is like condition push down, but push down for a specific case. Push down from where to on. To show this optimization, I will use my machine and ClickHouse local. Create table users, insert something to users. And now I will do a self-join, and filtering. And this query is somewhat unnatural because here I join a table to itself with the condition 1. So I did not use any condition. It is effectively cross-join. But it is inside a subquery, and outside the subquery, I have a real condition. So I would expect that this condition will be pushed down into the on section. And this query is not slow. It takes 2 seconds. But if I enable the new optimization, it will take 0. Yeah, much better. I thought we already had this optimization, but actually we have it in 25.4. And yet another optimization for joins. Optimization with dynamic sharding. Dynamic sharding of the query pipeline. So let's suppose you join tables by their primary keys or prefixes of primary keys. And if you do this, ClickHouse can parallelize data more efficiently. Even already in previous releases, ClickHouse does parallelization for joins, for both sides of the joins, for filling the hash table, for joining this hash table. But now it can do it better, even better. And again, let's take a look. Now I will connect to my ClickHouse server. It has version 25.5, not even 25.4. It is the master build, the latest master build. And I will use my table hits. The table hits, it contains test data about page views ordered by counter ID, which is some sort of a website identifier, date, user ID, and so on. And let me do self-join of the hits table. It contains URL and referrer. And I would like to create a graph of web visits by comparing referrer to URL. So I will create a sequence of visits. And I will also join with the same counter ID, the same event date, user ID, and only then joined by this condition. So a single user visited some page and then jump it to another page. Okay, and this join takes 4 seconds. It's quite good. 5 gigabytes per second, 54 million records per second. But now I can make it even faster, supposedly. Supposedly, because let me ask Mark. Mark, what do you think? How much faster it will be?
Let's say it's going to take 2 seconds.
Okay,
Anybody?
it was 3.5. Now you
Yeah.
say it will be 2 seconds.
Yeah, I say 2 seconds. Anybody else? Another guess? Let's see if we got any on YouTube. No guesses. Come on, somebody.
You know, Mark,
1.1. Ramazan says 0.9. Ramazan's always good optimism.
yeah, I appreciate your optimism.
Anybody less than 0.9? Miguel agrees with me. 2 seconds.
It should be faster, but the point is,
Yeah.
the query was already parallel. Now it will be also parallel, but in a different way. In a different way that could be better. That could be better. 2.8. Let me try again. Yeah. So yeah, it is faster. Maybe 1.5 times. So the point is now it splits data by independent ranges of the primary key. And then these independent ranges can be joined completely in parallel, completely independently. So it is more efficient. Okay, nice optimization. What else? Now something interesting. And the most interesting thing is the first implementation of correlated subqueries in ClickHouse. Let me remind you, what are correlated subqueries? They are subqueries that reference columns from the outside. Like in this example, we select users and filter them by a subquery by this condition that another record exists in another table. And this table is filtered by the value from the outside. And until recently, these queries were unsupported by ClickHouse. And correlated subqueries can be present in different contexts, like exists, like in this example, not exists, in, not in, scalar expressions, equals any, equals all, etc. And in the latest release, we support just a single case correlated subqueries that are present in the exists operator in the where clause. Let me try to show you if it works. Again, I will use ClickHouse local. Let me create some tables, insert some data. Yeah, users and users too. And I will do some filtering. You know, typically I don't write queries with correlated subqueries because I can write it simpler. But for some reason, some people do it. They probably have their brains work differently. And they write these queries, and we have to support these queries. First of all, it is not enabled by default because it is the latest experimental feature. So let me enable it. And now it works. And even more complex queries work, like subqueries with union all, when each of these is a correlated subquery. Yes, it works. No surprise. Okay, another interesting feature, a scheduler for CPU resources on a server. A scheduler that can do fair scheduling according to specified priorities, specified workloads with different weights, different limits, different priorities. Let me explain what you can do. First, you create a resource. You have a name of this resource, and this resource will control the number of threads, worker threads in the queries, and master threads. So each query will start a master thread that will control worker threads. And you can limit the number of these threads, like you create a workload named admin that will just limit the number of concurrent threads for both types by 10. Then you create a production workload with another limit, 100 concurrent threads. And yet another workload, analytics, with another limit. And this workload will be inside the production workload. So it will additionally limit the number, and you can create multiple workloads inside a single workload. So there will be two, analytics and ingestion. And analytics will have weight 9, and ingestion will have weight by default just 1. And it works in the following way. Until you reach the limit, you get all the desired resources. But when the limit is reached, analytics workload will use 9 out of 10 resources proportionally. And the ingestion workload will use 1 out of 10. And for every query, you just specify the workload, you classify the workload, and it will work accordingly. And you can limit these resources separately by the amount of CPU in worker threads and in master threads. It is pretty nice, good for multi-tenant systems, multi-user systems on a single ClickHouse cluster. Okay, now let's talk about data lakes and Iceberg in particular. You know, we have specific people in our company that love Iceberg, that love Lakehouse, and these people appear to be product managers. So we have a lot of new stuff for Iceberg. The first feature is time travel, support for time travel that allows querying tables as of specific time in the past. To query Iceberg, I can use ClickHouse local on my machine. I don't need a server. So let me first create a catalog. I will create a catalog of type AWS Glue. It has to use some credentials. Here are the credentials. They are active, but don't worry. They will be invalidated after this webinar. But so far, feel free to use these credentials. So we created a database attached to an external catalog from AWS Glue. And we have some number of tables We will use this table containing 100 million of records. And to use the time travel feature, you just specify a setting and the timestamp in milliseconds. It works. So at this time moment, there were just 47 million records. You can also specify an identifier directly. Yeah, it works. It works as well. I hope we will also support human readable time, but now it is just a timestamp. And it works pretty fast. Yet another feature for Iceberg, metadata cache. It allows not reading the same metadata and the same manifest files repeatedly. So it is just a performance optimization. Let me again show you just for a little bit. First of all, let's do this query. I hope it will work on my machine. Interesting if it will be fast. Let me also use a server. And on a server, I will create the same catalog and copy paste the same query. Oh, actually, it works pretty well. 25 seconds. It is not like ClickHouse native speed. Iceberg is still slower than ClickHouse and probably will ever be, but who knows? Okay, 25 seconds. Now let's take a look at the metrics. And we have metrics about the cache, the number of cache hits and cache misses from Iceberg. And if we do another query from the same table, we should have cache hits. Okay, 15 seconds. Let me do it again. And also let me do it on a server. It should be faster. But maybe not. It is Iceberg. It should be as fast as Iceberg could be. 15 seconds.
Where's your ClickHouse server located?
It is in Europe, in Frankfurt, and the Iceberg data is probably in Paris.
Is it the one? I think I've been using similar one to you, and that's in US East 2. So it might be that's why it's a bit slower.
So if it is in the United States, we go across the ocean.
Yeah.
Internet, but nevertheless, we should take a look at the metrics. Okay, now we have 14 Iceberg metadata files cache hits. And if we do, let me copy paste this query. Actually, I do have a server in the United States, but now I will use this server. Okay, 7 seconds. Yes, it is faster. Maybe it is due to the metadata caching, maybe not. I can disable the metadata cache and try again. The easiest way is to do some simple query like count. Here is the count query. It is pretty fast, 0.2 seconds. But if I disable the metadata cache, that was not even available in the previous release. It is more than 1 second. Yeah, 1.8. Okay, what else? And also we have improvements for another data lake format, named Delta Lake. Delta Lake is a format from Databricks. And in the latest release, we enabled partition pruning. And we did it quite easily. Actually, not so easily. We replaced the implementation, and now it reuses the library from Databricks named Delta Kernel RS, because it is a library in Rust. And ClickHouse is a C++ code base. But we put a lot of effort to allow plugging in Rust libraries into ClickHouse. I even written an article named "A Year of Rust in ClickHouse." It is one of the most popular articles in the blog. So welcome if you want to read about the details. But the point is, it is faster, 4 times faster with partition pruning. You just enable this setting, and that's it. It is faster. And we also have support for Delta Lake on Azure Blob Storage if you need it. What else? What is interesting is that now you can create data lakes not in Iceberg format, not in Delta Lake format, not even in Apache Hudi. Now you can create data lakes using the native merge tree data format. So you can create a merge tree table, you can write into this merge tree table, and then you can attach unlimited, infinite number of readers that will subscribe to these updates and read from this table. It's like replication, but without replication in a lakehouse way. And I have another demo for you. But first, how it looks like. How does it look like? You create a merge tree table with a custom disk. In this example, it uses S3 object storage with special metadata type named plain rewritable. You write to this table as usual, and then you can attach arbitrary number of reader tables that are created on the same disk, but the disk is marked as read-only. It means that actually the data can change, but the table itself cannot change this data because it is just a reader. But what this table will do with this setting, it will monitor background updates for this data and automatically load new data parts. And you can even delete the writer table. It does not matter. Readers will continue working. So let me quickly show you on one example. And again, I will use ClickHouse local. And I prepared a table for you named Hacker News History. It should be a real-time table. So it has been attached in 2 seconds. It's pretty quick. If I do count, it takes 0 time, and the table contains 44 million records. Now let's do something interesting, like selecting the latest record. And you can see, yes, it is updated in real time. And it will be updated every minute, depending on the interval you specify. and depending on the activity on this website. And you can create like thousands of these tables on thousands of machines, create a distributed table, or just use parallel replicas to query this table with infinite parallelism. It is pretty nice. Now we have our guests, Amok and Sai, my colleagues from ClickHouse. So let me stop sharing and welcome Sai and Amok.
Thanks, Alexei. Excited to be here. And today we'll be talking about an exciting, release that we did. So let me share my screen and I'll just set the stage and then pass it to Amog. So just like a couple of weeks ago, we launched MySQL CDC Connector in ClickPipes in private preview. So this connector enables seamless data replication from MySQL databases to ClickHouse Cloud. And you can use it for both one-time migrations from MySQL databases and also continuous replication from MySQL, where you have MySQL for supporting transactional workloads and ClickHouse for analytical workloads. So the good news is that the MySQL CDC connector is fully powered by PeerDB, which is an open source data replication project of ClickHouse. So all the work that is in this connector is also open source. So users can deploy it anywhere and use it with self-hosted ClickHouse as well. So before I pass it to Amog, I will quickly share like the main features that this MySQL CDC experience comes with. So the first is it comes with blazing fast initial load. So this is where you can migrate your existing tables in MySQL with like terabytes of data to ClickHouse. It also includes CDC, which is the main like feature, which is continuous replication. Under the covers, you can use two modes of replication. One is the GTID based replication, which is the recommended approach because it is resilient to failovers as well on the MySQL side. It also supports file position based replication, and under the covers, it's all bin log based, and bin log is very similar to write ahead log in Postgres. So bin log is for MySQL. Third is the CDC experience also supports automatic schema changes. So if you add new columns, drop new columns on the MySQL side, those are automatically replicated to ClickHouse. Fourth is the experience supports native data types, including vectors, unsigned int, like geospatial, etc. So one of the philosophies with which ClickHouse and the ClickPipes teams operates is we are very quality first, and we are very purpose built for the data store. So we took into consideration whatever MySQL has, let it be data types, let it be the right like modes of replication, let it be like the fastest like CDC and initial load experience while building this connector. We also support in-place editing. So you can add new tables as a part of the CDC replication. You can change sync interval, which dictates data freshness of the replication, and many other like settings. In-place resyncs are also supported. So in scenarios for whatever failures you had to resync the entire like replication, you can click a button and like resync the data. The ClickPipes experience is fully managed, so it comes with like inbuilt metrics, monitoring, logs, HA, right? And as I said, it is powered by the PeerDB project, which is fully open source, so you can use it with self-hosted ClickHouse as well. And last but not the least, it is fully integrated into ClickHouse Cloud, so there is no need of any external ETL tools. You just like add the MySQL data source and get going with replicating data from MySQL. So with that, without any further ado, I'll pass it to Amog, who will do a demo of all of this. And after that, I'll take questions. So yeah.
Thank you so much, Sai. And yep, let me just share my screen. Okay, I think we're good. So the way you would create like a MySQL ClickPipe is you would head over to like your ClickHouse Cloud console, and you would see like a data sources tab here on the left. Once you click on this, currently, as I said, it's in like private preview, but once we like enable it for you, you'll see like a MySQL tile here. Once you fill it, like, you'll see a form, and I've gone ahead and like pre-filled all of this. Pretty standard stuff, like you enter your host, your port, your admin, and your password. Notice how unlike Postgres, there's no like database field, because that's how MySQL works. Here, like you can select like your application mechanism. As I said, like we support both GTID and file position, but GTID is recommended, which is why I'm selecting it here. There's also like SSH tunnel and reverse private endpoint, which for this demo I'll not be showing. But if you want to connect to like your RDS instance, but you don't want to expose, like your MySQL instance to the internet, you can opt for either one of these. So SSH tunneling is like via jump box, and private endpoint is like private link. So moving forward. Here, like as I mentioned, like you can configure like sync interval and things like this. So I'm changing the sync interval to like 10 seconds. Here, the compression is talking about like protocol level compression, which like MySQL supports. And you can enable this here as well. The table picker is like very similar to like the Postgres ClickPipe. You can like select an existing ClickHouse database, or you can choose to replicate to like a new ClickHouse database, and we'll create it for you once you like create the ClickPipe. But for now, I'm like choosing this MySQL demo database here. You can like preserve null values from MySQL. So like if you were to check this, then we will see like if the column is nullable on MySQL, and if it is, then it'll be nullable on ClickHouse. I'm going to go ahead and select like a table. So I'm going to select like this events table, and I will add the users table later. Here you can deselect certain columns. So for example, if I see like this event blob, JSON is like going to be very big and it's not needed, I can exclude it. In like advanced settings, we have an option where, so the ClickPipe will create the ClickHouse tables for you if they aren't existing already. And when the ClickPipe creates the table for you on ClickHouse, you can like choose to have it be like a merge tree or a replacing merge tree. And like here you can also configure like the custom sorting key for your ClickHouse tables. So this is basically in the replacing merge tree syntax, you'll see like order by. And this is like very crucial because it decides like how data is like deduplicated asynchronously for like your ClickHouse tables. If nothing is selected here, we just use the primary key of the table as both the primary key and order by on ClickHouse, which is what I'm going to do now. So let's go ahead and create this ClickPipe. For the sake of like simplicity, I'm just going to let it be full access, but here you can configure a custom role if you're like, very security conscious. So once the ClickPipe is created, it goes through various phases. The first one is where it will provision your ClickPipe. This is spinning up certain things under the covers in terms of infrastructure and so on. Actually, it would enter a status called setup, but that finished instantly. But first, it would create your tables on ClickHouse, and then it would perform initial load, which is what snapshot indicated there. And here you can see like this events table, which I had selected, has synced like 1 million rows over to ClickHouse. If you click on that link, you can even, it even takes you like over to the table on ClickHouse, and you can see like, the data loaded. You can see like the table schema. As you can see, like the event blob column, which I excluded, is not there. And like the order by and primary key is the ID. So heading back. So here you'll see like the status of the ClickPipe is running. So what that means is that it's finished like doing an initial load of the tables. And now it's like, it's in change data capture mode. So if I were to like head over to like dbeaver here, and like if I were to like, do a bunch of changes, give me a second to do those. So here I'm just going to do like, I'm inserting like 100,000 rows. I'm doing like some updates arbitrarily, right? So dbeaver can be a bit weird sometimes. Okay, seems like it's finished. So what that does is, Sai talked about like bin logs earlier. So we actually like, based on like the GTID mode which we selected, we're going to like get this change data over, and you can see like, this is like new incoming data synced to ClickHouse. And if you want to monitor this, there's like a separate table here where you can do that, where it shows you like, 100,000 inserts, updates, deletes, and so on. Here, like you can monitor like, the logs of your ClickPipe, to see like what it's doing. Coming over to the settings tab, this is where like you can do like various operations on your ClickPipe, right? Like for example, you can pause the ClickPipe. When you pause the ClickPipe, basically we will not be reading changes from MySQL. And like pausing the ClickPipe, like what it allows you to do is you can now edit various things, right? For example, if your password of your RDS instance has changed, you can like go ahead and you can update it here. Or what I'm going to show you now is, you can add and remove tables to the existing pipe, right? So the users table, which I mentioned earlier, I'm going to like add now. I'm not going to like deselect any columns. So once you update your ClickPipe, in this case, like I'm adding a table. So what that does is, it's first going to do like initial load of the tables you added, right? And then once like initial load of the new table is done, then it resumes and it goes back to like, CDC for all the tables. So here you can see like I just added like a small table users. You can like click on it, and as I showed before, like you can like monitor it over at ClickHouse in the SQL console. um, and yeah, that covers editing. And I can like just show like a few more things. For example, if you want to change like the sync interval and things like this, you can change it over here, again by pausing. And lastly, like as I mentioned, you can also resync all your tables, which is what this button would do. I'm not going to do it here because it does the same. It basically does initial load again, to a new set of tables, but it takes care of like swapping those tables out in place. So it's just a neat way of sort of recreating the ClickPipe without having to drop your ClickHouse tables or anything like that. And yeah, that about covers it for my side. Sai, like, did you have anything to chime in?
No, that is it. I'll share the link for signing up to the MySQL CDC private preview on ClickHouse Cloud, and feel free to sign up, and we will give you access to this experience in a couple of days, basically. So yeah.
Yeah, thank you, Sai. Thank you, Amog. Just a single question. So we have Postgres, we have MySQL CDC now. What is next?
Yeah, great question, Alexei. A bunch of things are being planned. The immediate one that we plan to focus is Mongo. So like work is getting started on that, and very excited about that because of the JSON improvements that Core has made, right? So Mongo is one, and there are other items planned around data lakes, which I will keep it as a secret because we'll come to that like in the next when we release Mongo. So yeah.
Okay. Thank you. So about integrations, there are a lot of updates for ClickPipes, such as private link support, Terraform provider, Prometheus metrics, notifications, TLS authentication for Kafka, etc. Metabase driver is now included by default, and we have a lot more updates for language clients. And a small bonus for those who are still listening. So, if you did not know that ClickHouse has an embedded SSH server, you can try this. SSH play at play.clickhouse.com. And it will open the same experience that you get with ClickHouse client. But you can use it on any platform. Any platform that has SSH client now can connect to ClickHouse. So you can connect from Windows, from Android, from iPad, whatever. We have planned a few meetups in the next week, in the next month. in the United States, in London, Istanbul, Shenzhen. But even more interesting is our first ClickHouse conference, Open House. You still have time to register. It will happen on May 28 and 29 in San Francisco. And there is a lot of interesting content in our blog about Rust, about MySQL, about our latest optimizations, about managing Kubernetes cluster, about many different companies using ClickHouse for observability and for security. And now we don't have any time for questions, but maybe just a single question. What do you think, Mark? Do we have 30 seconds for a question?
We need someone to ask a question. I don't see any questions. Hang on, let me check on YouTube if we've got any questions. Okay, we got a question on YouTube. Let me tell you the question. So the question is, are the query plan optimizations enabled by default, or do you need to enable them?
Most of them are enabled by default, such as push down of query conditions into on section, but some new optimizations are not enabled. They are introduced in the latest release and will be likely will be enabled in the next release, such as optimization with sharding by primary key ranges. It is not enabled by default, but it's supposed, it is not experimental, it is supposed to be ready for production. We just did not enable it yet, but you are free to enable on your workloads.
Cool. Otherwise, I think we are done. I think already some people are leaving because we are a little bit over 1 hour already. So I guess we'll wrap it up for this month. Any last words for us, Tyler?
It's a wrap. 25.4. Do share the video with your friends. Give us a star on GitHub. Join the community Slack, clickhouse.com/Slack with any questions you have. We look forward to seeing what you build and to talking to you in just a month from now.